Scala data type hierarchy. So this is the one. This is from the official doc. Whatever you see here, the diagram. This is from the official Scala. If you look at it, can you see this? So when you look at this, I told you clearly about data types. One thing we have discussed in the last class, point one. So understand this carefully because every basic is very important for you to know, learn. The first one is number one. Every data type in Scala is a data type in Scala is a class. That is one thing. So means there are no primitives in Scala. Everything is a class type or everything is an object. Okay, if something is class type, we can say that it's an object actually. So that is what is so every data type in Scala is a class or we can say is an object. Second thing, number two. Here, there is a hierarchy. When you talk about the data types, there is a hierarchy. So when you look at it, there is an inheritance here. There is a hierarchy here. What is that? All classes, whatever it is, are inherited from a parent called any here. If you see this, what is that? This is the parent class. From any, we have two child classes. One is a val type, and the other one is a reference type. We have something like any val and any ref. Observe this carefully. So, means we have two types of categories here. And when you look at it, what is that? So, from any is the parent for all classes here. If you see here, it is if you are from Java, it is something like an object class. Understood? Any is something like an object class. So from any two different categories, all value types are are coming from any val, and all reference types are coming from any ref. You got it right. That is one thing. Next one. After that, you can see any val has so many child classes. All value types. Value types means which are used to represent values. You talk about your basic data types. Like if you see here, uh, double, float, long, int, short, byte, unit. Unit is also a data type. Boolean, char. All these are child classes of any value here. And from all this, nothing is a subclass. For all val classes, nothing is a child here. Even nothing is a child for null also. If you see here carefully. And from any ref, all different other classes like any reference type, all values are this. And references means other than values. It can be a list, it can be option, it can be your defined class like employee, like customer, like doctor, like actor. It might be any custom built-in class. Okay, all this becomes objects. They becomes reference types. Means that is the point. And if anything is reference, what is that? By default, all these references has a child as a null here. Null has a child, nothing. Nothing is something which is child for value as well as null here. You see here, this is the hierarchy. Understand this, remember here. Because this is very important to follow here. So what is that here? Here, for everything, anything is derived in a scalar from a parent called any. It has two childs. One is any value. You have to follow a standard naming convention here. You have to follow this naming convention. Every word starting letter must be uppercase here. If it is a class or if it is a trait, you should follow this naming standard. What is that? Every word starting letter has to be uppercase. Suppose if you have two words, you can see A and B are uppercase. Suppose you have one word, you have just one letter uppercase, okay? And any has two childs, one is any val and any ref. Okay. Any val is super for all value classes. Value classes in sense all your data types. For all data types, this is a parent. And for this, the parent is any here, if you see the hierarchy here. Any has again two subchilds here. any ref and any val here. You can see this. You can see you have observed the diagram there. And all your data types are coming from any val. And all your reference types means reference in sense what is that your like all objects in sense like customer, like bank, like actor, like all this, they come from any ref. Remember this carefully. What is difference between any val and any ref? Any val is a scalar here. It has only just, we can only initialize only one value to that. We cannot initialize multiple values to this double or float or this thing. Any ref is an object. An object can hold multiple values inside that. Got it right? I will talk more on this when I switch to the OOP topic. Understood now? And finally, for both are, for this the child is for all these subclasses. Okay, there are so many subclasses here, something like double, something like float. Okay, for all the subclasses, what is that? The child is what is the gentleman? The child is nothing. Nothing is also a class again. And for all this any ref, the child is what? Any ref means any ref can have multiple classes like your collections list set or no customer, your custom built-in classes or some EMP, etc. Comma dot dot dot. And this can have a child. What is that child? By default, for all these object types, the default child is null here. Even nothing is a child of which one? Nothing can also be a child of can also be a child of this one. Which one? Null. Nothing is a can be a child of null as well. Clear, right? So that is it. I hope this is clear for all of you. Understood or not? Is that is clear for all of you? Till this point, all of you understood this? Anybody has any? Okay, that's really excellent. So this is the hierarchy here. Okay. So this is how your total data type hierarchy looks like in a Scala here. Like this. Understood? It looks like this. Clear? Madhu, can you see this here? Yeah. Parent as any. From that we have two childs, any val and any ref. From any val, all these value types are inherited. From any ref, all objects types are inherited. And all reference types have child as null. All value types has a child as nothing. Nothing is also child for null. This is the hierarchy. So that is it. Now next one after this. So that's about the hierarchy. Remember, we are going to talk more on this. Now, let me switch to the operators topic today. I'll finish off operators as well as typecasting today. And then we will switch to the control statements. We'll work more on programming part. Okay. We keep working more on. Any is an interface. There are no interfaces here. There is a concept of triads here. So there might be triads. Okay, any might be a triad here. It might not be an interface. Okay. Understood? There is no interface concept in Scala. What is there we have? Instead of interface, we use something called triad. Triad is almost similar to interface concept in next operators. What is an operator here? All of you are good till this point, right? Yesterday and day before yesterday, I mean on Friday we have discussed all the data types. We have done some programs. Now let's continue further. And we have seen how to write a program in Eclipse as well as in the command line and how to test them. And the basic structure of a Scala program, how to create an object, a singleton object, instruct, and how to write declare main inside that. We have verified, observed all that. Now, arithmetic. What is an operator here? An operator performs. An operator is nothing but a symbol. What is that? Is a symbol which performs an operation. Okay, that is one thing. Next one, we have all these operators in scale. If you see arithmetic, relational, logical, bitwise assignment, we don't have unary operators here like plus plus minus minus I plus plus I minus minus. If you see, most of you would have observed that operator in C, C++, Java, C sharp. But when you come to scale, you don't have such operator because the reason is plus plus applies an incrementation on some variables. Whereas most of the data in Scala is immutable. If you declare something as val, an immutable data. When you apply plus plus on immutable data, it won't work. It leads to some errors. So that's why not to give not to change the meaning of what Scala is applying, because we discussed that Scala provides immutable objects. Immutability is one of the core strength of Scala. And when you apply plus plus, then there should be a change in the value. Means you cannot make all the time your objects as immutable. That's why that increment operators are not applied here, like in increment in sense unary. We can increment variables, no doubt about that. But unary is not applied. Okay, that is next one. So now, what are these means? Operators perform some operation. So it's a symbol which performs some operation like arithmetic, relational. Arithmetic in sense, what do we have? Addition, then subtraction, then next one is division, multiplication, division. Division can be of two types here. If you see, it can be one is it can be a remainder operation or it can be a quotient operation. So for addition, what do we use? We use plus. We know, all of you know this. For subtraction, we use minus, and for division, multiplication, we use asterisk. And for remainder, we apply percentile, and for quotient, we apply what is that? We apply slash. So these are arithmetic operators in Scala. Got it right? Following? So if you want remainder, which operator should be applied? Percent. And if I want quotient, then I should apply slash. So what you do is you do a small program now. What do you do? Start doing a small program. Write a program. Write a Scala program to demonstrate okay, arithmetic operators. Just for practice purpose. So what arithmetic operators we should apply? Addition, subtraction, multiplication, remainder, quotient. All 5 different operations. Take a program, open program, start doing that program with these operators. So do it now. What do you use for that? Can you use Eclipse? You know how to, all of you have Eclipse, installed Eclipse in your machine. All of you have Eclipse here. Okay. So what you do is use your Eclipse here. This is how we should use it. In the last class, it was a good session. We had discussed about string interpolation, all that. Now you do the same. So let's apply Eclipse here. Okay, come on. Open Eclipse, create a Scala project, choose your JDK. Then what is that? Just create a simple file, start testing the program. Anybody have issues? Ask me. I will show you one more time if you want. Okay. If you have issues with downloading Eclipse or if you have issues in creating project, you can always ask me. Okay? Now test this. Write a program for this to test arithmetic. I'm giving you just 2 minutes to finish this. Then I will show you how to apply that. And then I will switch to relational operators after that. And I just want to ask you, I don't know, how many of you really know the importance of scalar? The right, if you want to, if you want to become a big data engineer, mastering scalar is one of the most essential thing in big data. Okay, so those who are serious, no, serious learners of big data, you need to learn this scalar. Okay, I believe many people don't know how scalar is really useful, but when you are in big data, this is one of the most happening language. You can post in the chat box, guys. Once you finish, please just post your answers in the chat box if you are done. Okay. Still, if you have issues, you can ask me. Don't hesitate. What I need is I need someone who has really that passion to implement and who have to passion to do something on this big data. One more announcement is soon we are going to start data science sessions in the weekends within a couple of weeks. So if anybody is interested, you can join that data science sessions. Okay, so all are free sessions and the deeper discussion will be done on everything. Okay, we had enough time so far on this. I'm going to show you how to do this. Open Eclipse. All of you know how to open Eclipse, right? Don't hesitate. Please ask me if you have any issues, but make sure that you are applying it. Otherwise, there is no point of you know learning. If you just see, you can't improve your skills, guys. You have to practice. You have to apply. Otherwise, this syntax is all that you can get from the Google, sir. You don't need to attend sessions. There are so many YouTube videos also. So Scala object, let us see this now. I'll just name it as some operators dot something. And use object here. We didn't. We are not working with classes and objects. Even there, we need this one for testing your program. You need at least one singleton object, even though we use classes as well. Put your main. This main is very important in this in this kind of what is that programming languages. It's actually indicates the start of the program. Okay, now at least define two variables, declare two variables from keyword to find arithmetic operations. You can use this C comment, CPP comment here. All comments are supported here. C comment, C++, Java comment. All these comments are supported here. So this is arithmetic operators. We are testing arithmetic operators. Using comments is a good habit, sir. Okay, that is one of the standard use of programming. So I'm going for val some a colon int equal to, right? You have to declare at least two variables, val b colon int equal to 20. Now you can straight away start doing arithmetic operations here. Val c equal to a plus b. Okay, of course you need to define this data type here. So similarly, you can define remaining other variables here. So val d equal to a minus b. Okay, val e equal to a into b. Val f equal to a percentile b. Val g equal to a slash b. Now you have to print all this. How do you print a system dot out dot println of so right? You have to use an SOP here. Okay, this somehow this is not supporting IntelliSense now. Control space bar, it will automatically show all the list here. But you can directly use print also. I think we can use println. Can you see here now? When I say print or println, we don't need a system dot out dot println here. So go for directly using print here, println or print, okay? Because internally it is using system dot out dot println itself. So println and just print all your values. The sum is okay. The difference is you can just say that the sum is okay plus c. Okay, you can also concatenate, but now print one by one to print the text as well, so that it will be meaningful for us. Okay. So what do you do right now? The sum is the difference is okay. The multiple is and then the remainder is the quotient is. Just add some meaningful uh, statements in the prints. Okay, it increases readability. Okay, print d, print e, print f. Okay, print g, c d e f g. Okay, fine, that's enough. Just run this program. Right click on this and just say run as a Scala application. Can you see here now? Okay. Remainder is 10 and quotient is 0. You can just give some other values. Give 10 and 5. Okay. Then rerun it. And then you can see the different output this time. You can also apply some, you can directly use that control keys if you want. Okay. Can you see that? So this is how the output is. Got it? Okay. Anybody needs to test it? See, you have to become independent, sir. You should keep applying yourself. That's why, if any gap is there, first try to fill it. That is my request. Okay. Clear now? All of you are clear? So that's idea about this one. Can I get an yes or no from all of you guys? Can you just tell me you understood this or not? Or if you have questions, you can ask. Next after this is relational operators. What are these relational operators? They are used to compare values. What does they do? They compare values. What is that? Something like greater than, less than. Okay, greater than or equal, and then less than or equal, and then equal, and then not equal. These are all relational operators. They compare values here. Okay, I'm going from very beginning, sir. So you might, some of you, if you have some idea, still just try to understand like how we do the same in Scala. But the fundamentals are same anyways. All these are developed from C itself, including Python. Basic fundamentals never change from language to language. There will be small here and there, that syntactical difference is there. The approach is same. Okay, fine, no issues. So these are used to compare values. You know, whenever we apply relational operation, any relational operation, so what it does, any relational operation return a Boolean value. Suppose you see, sir, 10 greater than 5. It should return some Boolean here, either some true or false. Means usually we apply relational operators to compare values, which we can call them as conditions. Okay, they form the conditions. On that conditions, some validation is applied, and that will return either a true or a false here. Maybe you can quickly check here. For this, I am not using this Eclipse. We can quickly test from Scala prompt. These are small things, right? Suppose 10 greater than 5. I'm directly using the constants to verify this, to just check a condition. When you write this, you can see it's returning true, or 10 less than 5, it returns something. Or 10 greater than or equal to 5, it returns true. 10 less than or equal to 5, it returns a false. 10 equal to 5, it returns a, or it returns a false. Okay. 10 not equal to 5, it returns a true. Okay. To understand this, you don't need to be anything. You don't need to know anything. If you just observe, then you can easily understand that this is nothing but a simple thing. Understood now? Right. So that's about relational operators. So why don't you test it quickly in the command line here? How this relational operators works here. They just return a Boolean value here. Any relational, not just this. Any relational operation results in Boolean. Okay. So test it quickly. Test it in the command line. If you wish, you can test it in Eclipse as well. You can compare all the variables and take two variables, compare, apply all the relational operators and see how this Boolean values are returned on each condition. Okay, you can check like that as well if you are interested. Following, sir. Okay, all of you are good now. Next one, logical operators. What is logical? Did you finish testing this? I'm just waiting for you only. If you finish testing, then I'll switch to logical. Just confirm me if you have done it or not. Just give me some answer in the chat. Tested? Okay, that's good. Perfect. Because all the time you keep practicing, that is important. If you don't practice, again you forget, sir. Quickly you will forget everything. Okay. Logical operators. What is this? Logical means we are using it from school days. Probably somewhere in your school, your grammar teacher, your English teacher would have taught this. If you want to combine two sentences in grammar, we use and or operations. You remember, right? We use and key, and word, and or. They are called conjunctions. If you remember in English, somewhere in the school days. Now. Same thing here. Logical operators are used to combine two or more conditions. You have multiple conditions. all conditions has to be combined. Then in such cases, either we apply and or or. So these are used to what? Combine conditions. Okay, that is one thing. Second thing is we have two types here. One is and operation, and the second one is or. We have not operation. Not is not for combining. It is used for giving some negation. Understood? It is used to apply some reverse kind of operation, inverse operation. If you have true, when you apply not, you get false. If you have false, when you apply not, it gives you true. That's not. But here, when you talk about and or, these both are called as short circuit operators. Means they are used to combine conditions. And when should we use and? If every condition in the expression, suppose you have so many conditions, okay? If every condition in the expression must true, expression must be true. And what is that you have to do? You have to apply and operation. Okay, like how? I'll just show you. A greater than B and A greater than C, something like this. And I can also say and A greater than D. Means when I apply and between two conditions, here, if that whole operation should be true, then every condition here must be true. If any one condition is false, then that operation is false. Understood, right? So here, what do you do right now? If you look at it, this is simple idea about AND operation. What is an OR then? At least one condition should be true here. See, at least minimum one has to be true if OR should be true. Of course, if multiple conditions are true, still it's good. Nothing wrong in that. But how many conditions should be true? At least one condition has to be true. Okay? Following, right? That is what that is OR operation. Okay, then maybe you can ask me, means if I have two or three conditions true, is there any problem with that? So the advantage with R is minimum one has to be true if that operation should return true. Means if you have two truths or three truths or four truths in an operation, still it is true only. Okay, got it right? Huh? How many should be true here if R should return a true value here? At least one condition should be true. That's enough. If every condition is true, also is fine. No issues for us. Okay, but if R should be true, minimum one condition has to be true. That's the point. But AND is not like that. Every condition has to be true. If at least one condition is false, the whole condition is false. That is AND operation. And here you can just use like this: A greater than or equal to some 35, or A greater than or equal to 45, something like this. Okay, like this. You compare like this. R is used applied like this between conditions. Okay, but of course here we need to use operators here. Whenever we talk about operators in scale, we use this operators. What is that? For and we apply this one. We use double ampersand. For R we apply double pipe. Okay, because I keep doing Scala yesterday. I was in Python a bit there. So, but in Scala we don't use and or keywords. We apply and operator and or operator. Something like this. Okay. Suppose 10 greater than 5 and 10 greater than 4. What is this? Both are true. That returns true. Okay. And then here you can also say 10 greater than 5 or 10 greater than 7. Any one can be true here. Sorry, I have to apply operator, right? use keyword. Clear now? This is how we apply which operator? Or operator. Following? Understood, guys? So you can test it quickly how to apply this and or operators here. Will you test it? Not means it applies like this. It is applied like this. What is that? Something like not of true. It returns false. Not of false. It returns true. This is how not can be applied. Not of 10 greater than. Okay, you can try like this. What is that? Not of 10 greater than 5. Actually, it is true. When I apply on a condition like this, it returns false. Okay. What it is saying, I'll do one thing. Let me put a bracket and see. Okay, that is the issue. Understood now? Put a bracket there. Is it clear for all of you folks? Understood now? Understood or not? All of you. So let's move to the next topic. Bitwise is not that necessary now. It's a waste of time again for you. Let's switch to the assignment and then with that level 1 fundamentals of Scala is done. Means variables, keywords, constants, data types, hierarchy of data types. Okay, and the two different subclasses of any val and any ref. What is any val and what is any ref? What is subclass of all value types? What is subclass of all reference types? Okay, we have discussed all that there, that thing in today's session. So now assignment. What is assignment? We are already doing assignment. Okay, what it does? It is used to assign a value to a variable. Are we doing it from the beginning or not? Yes. So what it does? Something like a equal to 10. That is assignment. Or a equal to a plus 1. This is also assignment, sir. Remember, this is also assignment. You are incrementing, you are adding 1 to a and again you are initializing to a. This is also assignment. Okay. So now assignment can be in different ways. We can apply assignment on plus equal means add and assign, minus equal, subtract and assign, asterisk equal, multiply and assign, percentile equal, divide and assign, slash equal, again do the quotient and assign. Are you following, sir? Means assignment can be in different forms. It's not like this, just like this. You can also have assignment with the plus equal or minus equal or asterisk equal, all this. Greater than or equal. Okay, that's a kind of, you are seeing there, right? A kind of validation there. Now, okay, now let us just analyze this, how this works here. Suppose I have a simple analysis. I have a equal to 10. This is assignment, fine. But I say a plus equal to 1. What is this now? What happens here? If we expand this, I'm using plus equal. It is an incrementation here. What I'm doing here, this is a shorthand operator. What's happening here? It is incrementing the value of a by 1 and assigning the final result to the a itself. This is called a shorthand operation. So if you expand it, it becomes a equal to a plus 1. Okay, observe this carefully. So that's what happens here, sir. Okay. So finally, what is the value of a? After you perform a plus equal to 1 or a equal to a plus 1, what is the value of a here? It becomes 11. What's happening? It becomes 11, sir. Is it clear to all of you? So here I cannot say a plus plus, sir. This is not there. This is illegal. You try this, it will give you left and right view. Okay. Or if you say a minus minus, you know, still it's illegal, not recommended in scalar, not there actually. You cannot use something which your language doesn't support. Following. So we can quickly test it, sir. You can see here a equal to 10. Okay, of course, you know, right? How do you assign a value in scalar? Something like var. Do use var here, you know, when you are trying to modify the value, right? If you want to make it mutable, use var. You don't want to make it, if you don't want to change value, then only apply var. You remember, right? So var a colon int equal to something. Now you apply a plus equal to 1. What happens now? Print a. What happens to a now? A is not tensor. You can see when I apply assignment are there, value of a is incremented to 11. The same thing I can also write like this. I can say a equal to a plus 1. Then print a, sir. How much you got here? 12. Means we can do this in two ways. This is a full form here, expanded form. This is shorthand. Suppose in a program, you want increment by 1 or by 2, by 10, by 100, then you have to use this. You have to use this assignment, sir. That is very important. Okay. Following or not? Is it clear to all of you, sir? Can I get an yes from all of you or no from all of you? You can give anything, is fine. Is it yes or no? Clear to all of you? Okay. Right. Any questions, sir, so far? Any questions? Okay, fine. That's good to hear. Next after this. Clear now? So we are done with operators. You can test it like this. A minus equal to 1. This gives you some. Again, you can see 12 became 11. Suppose A into equal to 2. Then print A. 11 became 22. Okay. A percentile some equal to some 2. I am dividing by 2. It becomes what? Percentile gives reminder 2 divides 22 perfectly. So I get 0 here. Okay. And then what? A slash equal to something like 2. Anything is fine, sir. Print A. So what is happening here? You are applying some operation on A and you are trying to do some. Again, the same result is stored into that A itself. Got it right? So that's how this works. And just observe what you are doing. See how the result is coming here. That is very important. So we are done with what, sir? We are done with operators. And the last topic for today is a type conversion. So this is one of the very important topic you need to understand. You know why? Because in coding, type conversion is the most frequent operation you do, sir. So you get different types of data. You get string data, which is in the form of numbers, numeric strings you get. That numeric string you have to convert it to into type, sir, or float type. That is the frequent operation you perform in this kind of analytical languages. Okay, even the same thing happens in Java also. Because you get data in data sets, like in JSON or like in Excel. And that data, by default, it will be of string type. If it is Excel, by default, mostly it will be string. They give it as a string. Sometimes you need to convert back to int or sometimes to float. Applying casting is one of the most important operations. You need to understand that. So if it is C, C++, or Java or C Sharp, we apply a typecast operator. But here, these are not primitives. So as they are not primitive, we don't apply any typecast operator, but we use a built-in function which we call as instance. It's very simple, sir. Casting means you have two types, sir. I'll just show you here. So the topic is typecasting. I hope you are clear till this point, right? Before I switch to typecasting. Are you good with your fundamentals? Now we have done level 1 fundamentals of scale. Then I will switch to the level 2 fundamentals, which we call control statements. Okay. Then we move to the OOP concepts. Understood? There we apply more and more on different use cases. Okay. Then we understand different analytical related functions in Scala. Okay, the collection part, and then collections are very useful in Scala. Okay. And now I think you are good till this point. Now, switching to the typecasting. What is this? Typecasting means converting one data type to another data type. And what do you call this, sir? We call this as typecasting. And here you have actually two types of conversion. One is implicit, the other one is explicit. You know what is implicit, sir? If you are converting one data type to another data type automatically. So this is an automatic conversion, internal conversion. Compiler will do this. An automatic conversion is implicit. Explicit means here you need some external, you need to do some external operation here. You have to do certain, we have to apply some external function here. Then only we can convert explicitly, which is not possible implicitly. Something where implicit fails, there we apply explicit. Because we need a conversion by hook or crook. In such case, we go for explicit. In some cases, by default, conversion happens. But you need to understand where conversion is possible, where it is not possible in Scala. Understanding this point is very important. Okay, as Scala is implemented in Java, most of the rules followed in Scala are Java rules. Java is very strict with type conversion. Suppose if you go to C, C++, we don't have such issues. They are not strictly typed. Whereas Java, C Sharp, sorry, even C Sharp and Scala, these are all strictly typed languages. Here we cannot, no, strictly typed in sense. Here, upcasting is possible. There is something called upcasting. By default, upcasting is applicable, is possible, whereas downcasting is not possible in these languages. There is something called downcasting. Downcasting not possible automatically. It's possible, explicitly possible, not implicitly. And you can ask me a question, sir. You are bringing so many new terminologies. What is this upcasting? What is this downcasting? We don't have any idea about it. Could you give brief us on this? This is a very important concept to understand, because if you don't understand this properly, in many cases you do a lot of conversions. There you are going to get confused. But if you observe carefully for 5 to 10 minutes or some 15 minutes, then in many cases the conversion or how the data type upcasting happens, downcasting happens, you get a very clear picture. It is very easy. Just observe carefully. So listen it, it's enough. Okay, so you know the data types, right? Let's talk about value types. From now onwards, when I say value types, what do you mean by value types? Could you just ping in the chat box? Let me ask you questions. because I taught you the hierarchy of data types. We have just quickly discussed this. Okay. What is value type? Anything which is child of any value is value type. Usually these represents values, scalar values. Scalar in sense like int type, float type, double type, unit type, boolean type, all our built-in, built-in values, data types. They are value types. Now you tell me, okay, these are all value types. Tell me the sizes of these data types. Suppose I have a byte here. What is size of byte, gentlemen? Can anybody ping in the chat box? What is size of byte? What is size of byte? Okay, 1 byte. Okay, size of byte is a 1 byte. What is size of int? Okay, let me take int now. What is size of int? What is size of int? Some of you give me some answers. Okay? Let's just have some understanding. Size of int is 4 bytes. Okay. I have discussed this. Now, if you look at a small diagram, I'll just show you a small paint analysis. So I have a variable which is a byte value here, something like
Porika,
so
ఆడుకోపో తల్లి ఆడుకోపో పెట్టేసి ఫోన్ పెట్టేసి ఆడుకోపో వెళ్ళి
okay, I think it's unmuted. Fine. Usually kids, they, I understand, like where some int not int actually, take bytes, byte equal to 10. Now the range of byte, right, sir? Just see here, observe this carefully. Where some a colon byte equal to 10. This is fine, sir. I would like to ask you a few quick questions now. Whenever, it's okay, Suresh. That happens when you have kids. No problem. So here, I was talking something. What is that? Okay, I got little deviated here. Fine. You have a byte, right? What is the range of bytes? And do you remember? Will you tell me what is the? You told me the size. What is the range? Range of byte is minus 128 to 127. Remember this. If you forget, it is fine. Just for understanding analysis purpose, this is the range. Now I took 10 here, sir. What is 10? What is 10, sir? To represent integers, how many data types are there in Scala? We have discussed this on Friday. How many are there, sir? To represent integer, how many are there? How many data types? Answer, sir. Just give me, somebody just answer this.
4. 4.
Yeah. Yes. What are those 4? I'm trying to recollect. Might be assuming that you forget, so that at least you remember it. Byte, short, int, long. Isn't it or not? To represent integers, we have 4 different data types. Yes or no? Right. So by now I have 10 here. What is 10, sir? 10 is an integer. All of we know that it doesn't have a fraction, right? But by default, 10 is what type? It can be any one type. It can be either a byte, or it can be either short, or it can be int, or it can be long. By default, it has some nature, sir. It has some nature. What is that? Okay, if a kid is there, just a quick example. He has either nature of a father or nature of a mother. Of course, genes might be from both, but he has one kind of nature. Default nature will be there. He might behave as a mother, or he might behave as a father. Same thing here. When you have 4 types, among those 4 types, this represents by default, this is not all 4 but one type. What is that? All integers are by default int types, sir. What type? Int type. I can prove this also. How? These are all very important points, sir. I'm not sure whether people discuss these things with you or not. Other things, this sizes, this ranges, people talk in the books, everything. But these things you have to be very careful. Understood? You might see them in books, but not sure. That will be clear for you. Now you see, sir, same thing. I'm giving it as 200. If I give 10, it's okay, fine. If I give until 127 also, it's fine, sir. I'm giving 128, then immediately we have an error here. Can you see that? Can you see there, sir? What it is saying? It is saying, what it's saying? Found int required byte. Means what's the point here? By default, now once the value of this range of byte is exceeded, it became an integer, because by default it is an integer, it's not a byte. When can we say an integer is byte? If it is within the range of byte minus 128 to 127. If you exceed that, then it is not byte, sir, it becomes integer. Got it right? Huh? This is one thing you have to remember. What is that, sir? This is one thing you should remember. Got clarity, no? By default, all integers are int type. Second thing, I have 10.5, sir. This is decimal. To represent decimal, how many data types are there for us? How many data types we use to represent decimals? What is that? Float and double, isn't it? Now I have a value here, sir. What is this now? Is it float or is it double? By default, it has some nature. Of course, decimal can be declared with float or double, no doubt. What is this by default? Is it an integer or is it is it a float or is it a double? It has some default nature. What is it now? Can anybody tell me? Otherwise, remember this. By default, all decimals are double types. It's not float type, it's a double type. So if you look at this, it is a double type, sir. Is it following? Is it clear now? Suppose you see, sir, small example. I give something like, float f equal to, okay, 10.5. See this. Enter. Okay. Of course. Am I missing anything? Yes, I am missing something here. Leave this. So this is correct declaration. Okay. I declare like this, enter now. When I give a decimal to a float variable, still it is saying mismatch, type mismatch. It is saying found double required float. What is this? You might be wondering. Array, I have given a double value to a float, decimal, still it's throwing error. Why? Because this is not float, this is double. You cannot initialize double to a float, sir. Why? We will talk quickly. If I should make it float, I have to suffix it with small f or capital F. Enter now, it will work. Or put capital F, it will work. Now it is float, sir. Okay. When you assign a decimal literal to a float, you have to suffix it with the small f or a capital F. Otherwise, it becomes double, sir. The concept of typecasting here itself, okay? You see here now. Suppose you take this. I am initializing 10 here. What is 10, sir? 10 is an integer. Does it have any fraction, sir? No. But to which data type I am initializing? Float. Enter. Any issue is there? No issue. Suppose you take int, sir. Okay, means here this is upcasting. We are promoting an int to float. There is no issue. This is upcasting, sir. Okay. And then now you take int here and you initialize double. Just initialize like this. Enter. What's happening? It is saying type mismatch double, found double required int. And what is this, sir? Means here we are doing downcasting. What is size of double here, sir? Double size is 8 bytes, int size is 4 bytes. Just for common sense, let's just quickly understand with some common sense. Just to get a quick idea, I'm just giving a small tip. It is not a professional thing to point, but still just to remember quickly. Remember this tip here. See, in Java, sorry, in Scala, we can promote, even the rule is same of Java only. We can promote smaller data types to larger data types. It's called upcasting. That's what we call upcasting. But we cannot demote bigger data types to smaller data types. This is downcasting. Are you following? This is, just remember this tip. But the statement is not 100% valid in all the cases, but it is valid for 90 to 95% cases, except when we move from where into to float, because both have same sizes. I'll talk more on that. But remember this tip. What is that? Upcasting means moving lower level data type to higher level. Downcasting means higher level to lower level. Remember this point. I am demoting here. I am trying to convert double to int, which is illegal here, because the size of double is 8 bytes. The size of int is 4 bytes. You are trying to put 8 bytes in 4 bytes. Is it possible? Can a rich girl can marry a poor boy? Possible. Maybe in real life, here and there, it's possible. But in programming, compiler doesn't agree. Usually, this doesn't have, even the parents doesn't agree in most of the cases. Isn't it? What do you have to do in such cases? If your compiler is not supporting, then you go for what? You go for explicit casting. Implicit means you can see now you can convert into to float. Compiler is agreeing. Okay. Can you see this now? You are converting into to float, no issues. But you try to convert float, that double to int, not possible. Why? Possibly there is a possible loss of data here. When there is a possible loss of data, it doesn't allow to do that. Compiler don't agree. Got it right? So it's not possible. But still you are asking, I want to do it by hook or crook. I want this decimal to be converted to int. I just want to remove that decimal point fraction. What should I do then? Then you can do one thing, sir. What is that? You can say a dot as instance of what, sir? So now you have to apply like this, as you have to use this simple function here as instance of okay. I will just show you here. A colon int equal to a dot as instance of, use square brackets, don't use a round bracket parenthesis here, use a square bracket. Now this a, okay, a is an integer. Of course I should do one thing here. First you take a double value here, sir. First you define double x colon some double equal to some 10.5. Now I am trying to initialize int, it won't work. Where a colon int equal to some x, it won't work. It's not possible to initialize like this. Enter, you get an error. Now what I am doing now, you can see x dot as instance of what? Now x has to be converted to int, sir. Then what should I tell here in this square brackets? Pass int. Enter. This time it's converted. Can you see? The decimal part is removed, sir. It's truncated because int don't accept precision. Following, right? This is the idea about what, sir? This is the idea about type conversion. Following. So if I want to convert downcasting, or if you want to convert higher level to lower level types, it's not possible automatically. Then in such case, I have to go for what is that? Explicit conversion. And for that, we have to apply this function here. What is that? As instance of, it looks like this. As instance of, now x has to be, x is double. It has to be converted to int. So we should apply as instance of on that x. And you have to pass that to whichever the data type you should convert, that you have to mention here. Automatically this x will be converted to the type you specify here. Here the left side variable is int. I want to convert x to int type. Whatever it is, the left side variable, that you have to convert, the x has to be converted to that type. So I apply casting with to int here. Now the x gets converted to int. In that process, the precision will be truncated. But I don't have an issue this time because I don't mind losing some, possible loss of bits might be there. Then still it's fine for me. It's good for me. Then I can go for explicit conversion like this. Okay. So this is the idea. Still, there is a bit of discussion on this. You need to understand possible conversion hierarchy tree is there that I will show you tomorrow, and then we will summarize explicit and implicit conversions, and we'll see a few samples on this. And then I'll give some small samples and ask you to just validate them so that you get some clear picture. So we can stop there. Got it right? Understood, sir? All of you? Any questions? Any questions, sir? So shall I quickly summarize what we have discussed today? We have discussed so many things. So today, I think I have discussed a couple of important things. That too, we have seen data types hierarchy. I will ask some quick questions, answer there. Which is the superclass of all classes in Scala? We have seen a data type hierarchy. In that, we have seen some class is a superclass, which is at the top of your hierarchy. What is that? Very good. Okay. Just type in the chat box. What are the subclasses of any here? What is subclass of any? We have two subclasses by default. What is that? Okay. Come on, guys. I'm expecting answers from all of you. Why don't you just try to type in the chat box? Okay. Any type, any val and any ref. Both are classes. Both are classes. Okay. Any val and any ref. Okay. Both are classes. So you have to follow naming standard. Anyhow, when you answer it is fine. But remember, I will talk about naming standards tomorrow. So now any val is used to has all subclasses as which type? Dash type. It has all subclasses as which type? Values type. Very good. Value types in sense all basic data types here. Any ref has subclasses as which type? Any ref has subclasses as what, sir? You need to get a clear picture on all this if you want to follow Scala properly. These things are very important. Any ref has subclass as the object type. Very good. Okay. Then which is the subclass of all these value types? What is the subclass of all value types? See here. If you want, you can see and answer, sir, because understanding concept is important. Which is the subclass of all these reference types? At least why I am trying to repeat it again and again, because these are very important things. You don't understand these things now, and people don't focus at this level, and when they go to the next level they get confused and they say Scala is difficult. The problem lies in the fundamentals, not with the advanced topics, sir. If you are really clear with fundamental, then then you can easily go with any language. Okay, right. Next after this is what else I have discussed today. After that, I have seen casting here. No. By default, all integers are what type? All integers are dash type. Integers are all decimals are what type? All decimals are what type, sir? Sir, you don't have time again to go and practice and to go and revise all these things. You should get everything in the class itself. If you spend 1 hour has to be there in the mind. Understood? Right. So, next one. Other things is I have discussed casting. How many type? What is a casting? When should we prefer casting? Type casting. Intercaste marriages in real life also. When do you prefer that? You want to convert one data type to another data type. How many types of castings are applicable, sir? How many types of castings are there? What is that? What is implicit? Just tell me in one word. You don't need to go for lengthy sentences. What is implicit? Yes, that's all. Internal conversion, automatic, that's it. What is explicit? What is explicit conversion? Programmatic or, explicit means programmatic or external conversion. Okay. So manual conversion, that is also fine. Correct. Forcible conversion, that is also fine. Okay. Then when should we go for implicit? When should we go for explicit? By default, your Scala supports what? What casting? Upcasting or downcasting? Scala supports what kind of casting? If it is downcasting, then you have to go for. If it is downcasting, you have to go for. That's all. Okay, explicit conversion. And what is the function we apply for explicit conversion? Not instance of, as instance of. Okay. Okay. Because you didn't have breakfast, so you cut that as. Okay. Fine, no problem. Not an issue. So we'll discuss more on this tomorrow. Okay, I think you are clear. See, these basics are important, sir. You might think why this fellow is taking so much time and trying to grind us. You understand this slowly, right? See you. We'll meet tomorrow, sir. Your office time is already running out. Even I am also running out from my office time. Okay. We'll meet again on tomorrow morning. See you.